Electric motors are round. Wheels are round. It's a pretty natural impulse to combine the two. No lesser automotive luminary than Dr. Ferdinand Porsche did it first, inventing the wheel hub motor in 1897. He mounted two of them to his front-driven battery-electric prototype loaner Porsche. 3 years later he invented the gas-electric hybrid by fitting 4 hub motors to his elaborate 4-ton mixed coach. The one tiny rub, those 14-horsepower motors weighed around 320 pounds each. Modern materials and engineering have enabled dramatic improvements. For about 7 years, Protean Electric has been selling a 100-horsepower hub motor that weighs just 68 pounds. So why do all volume-produced EVs still mount their motors inboard? To minimize unsprung weight for optimal ride quality. Enter Silicon Valley inventor and serial startup founder Marcus Hayes and co-inventor Scott Streeter. They wondered if it might be possible to develop a wheel and motor system that weighed no more than a conventional aluminum wheel. As folks in their neighborhood so often do, Hayes, Streeter, and the Orbis Wheels team look to disrupt as many paradigms as possible. Without the gear reduction of a body-mounted motor, a hub motor needs high torque to act through the 1-foot lever arm from the hub to the contact patch. Wheels then need hefty structure to transmit these acceleration, braking, and cornering forces between the hub and the rim. Mass, cost, and rotational inertia instantly plunge with this approach. Mounting the motor so that it drives a rim-mounted ring gear, via a small pinion shaft, lowers the required torque to get the wheel spinning. It also greatly increases the electric motor's top speed. And guess what? Motors wound for high RPM instead of high torque, like those on a drone copter, can deliver the same power as high-torque motors using vastly less copper and hence weighing 1/28 as much. Bam, a cost and weight savings twofer. How does a hubless wheel connect to the car? Traditional suspension links attach to a carrier that supports the motor, brake caliper, and a triangular wheel bearing system. The car's weight bears on 2 pairs of rollers located at the 5 and 7 o'clock positions on the rim, a third set at 12 o'clock keeps the wheel from tilting. The inner and outer bearing race surfaces on the rim are angled to transmit side forces when cornering, and PTFE anodizing of the aluminum rim and Delrin rollers negates the need for lubrication. Hayes says his 9.5 by 20-inch prototype Civic Type R rear wheels, below, exhibit 1/5 the dynamic friction and 13% less rotational inertia than Honda's wheel. Covers and seals are expected to exclude debris, and typical air-cooled automotive-grade DC motors are tolerant of occasional, temporary submersion in water. I worry about those bearings and am eager to study the durability testing results once Orbis fits motors to the Civic wheels.